Welcome, folks, joining us early for our monthly lunch and learn today. Just going to give a minute here for Zoom to let all of you in. Let's see what we have. Yep. All right. We already have folks starting to join us, so welcome everyone. We'll be getting going shortly. Takes a little while for Zoom to let everyone in, and we did have quite a few folks signed up for this one. So lots of interest in thermal hydrolysis, or really any management solution for biosolids right now is of great interest, at least in the New England area. So good morning, Jim Dunbar. Welcome. Hello, folks. Thanks for joining us for our Friday Lunch and Learn. I'm going to give it 15 more seconds here. Yep, still have a few folks, slow drips and drabs coming in here. I don't want to wait too long because we have a lot of good material to go over and some interesting discussions, I think, at the end. So, all right, let's get going here. I want to welcome everyone to our 6th Lunch and Learn in 2022. Everyone's muted as you join. Hopefully people are used to this Zoom mode now. I'm going to ask you to stay on mute until the end when I can let you ask questions directly. There's also a Q&A function, so you can type in your questions as they come to you during the presentation, and we'll get to those at the end. There's a chat function as well, and I'll keep an eye on that. This session is being recorded, and the link to the recording, and I'll grab the slide deck, and we'll share that with you after the fact, and it'll be available on demand to any NEBRA members who may have missed this. So thank you very much for joining us today to learn about a technology, thermal hydrolysis, that's been on the market for a while now and continues to be a viable way to manage all sorts of sources of sludge. Specifically, we're going to hear about Lystek's patented process, and the primary presenter today, Ajay Singh, is a NEBRA member and very active on our research committee. And when I asked him to present on thermal hydrolysis, something that I was interested in learning about, and I thought NEBRA members would be too, he didn't even hesitate. And I know I may sound like a broken record, but I really never get tired of saying that the best thing about NEBRA is its members. So I want to thank Ajay and Listech as well, who's a website sponsor for NEBRA. And thank you for sharing all your knowledge with us. Like I said, Ajay is an active member of the research committee. He helped us develop the summer intern research project. He's judged at our recent poster contests, and he's quiet mostly and obviously quite humble, because I never knew I was in the presence of a legend in the business here until I read this book, The Other Dark Matter. And the entire chapter 11 is all about Lystek. And Ajay makes a nice appearance there, but he is the co-author, and the co-founder and technical director of Lystek International, and an adjunct faculty member at the University of Waterloo in Canada. Dr. Singh is an environmental microbiologist and biotechnologist with over 30 years of experience in designing and implementing bioreactor-based processes for wastewater, solids, fermentation, food, and bioremediation industries. And he's managed numerous full-scale operating projects internationally. He's authored 10 books and published over 200 papers in the area of bioresource management, and he also holds 17 international patents. See what I was talking about? And today he's invited one of his younger colleagues, an engineer, to help him with this webinar. Hannah Bennett is joining us today. She's an environmental engineer at Lystek International. She graduated from the University of Guelph and is an EIT with prior experience in environmental consulting. She's collaborated on various projects on bioprocess optimization, bioproduct research, carbon analysis and management, which I'm looking forward to hearing about, and business development activities for Listech. And as a current project coordinator, she supports the engineering, business development, and applications teams there at Listech and various LysteMize digestion enhancement projects, which we'll hear about. So with that, I will ask Ajay and Hannah, you can unmute and feel free to take the screen away from me. Looking forward to learning about the benefits of thermal hydrolysis.
Good afternoon, folks. Thank you, Janine, for the kind introduction and also inviting us to present actually in a NEBRA platform.
Would you just mind putting that in presentation mode?
Yes, yeah, I'll do that.
Thank you.
Right now. Yeah.
Great, that looks beautiful. Thank you.
And probably I'll just go. I'll close my video. And so, yeah, folks, so thank you, Janine, for inviting us to participate in this webinar. And this is actually very useful lunch and learn program actually NEBRA is having, and lots of good information every month we are receiving from NEBRA. Today we are going to talk about Lystech THP. It's slightly different from the conventional thermohydrolysis processes for biosolids. So I'll actually go through thermohydrolysis processes in general before going into and move it. Okay, so before going into detail of Lystech THP, and then I'll hand it over to Hannah for Lystech energy production and carbon displacement and counting and all that actually. So she has a good stuff there as well at the end. So as a overview, it's a different concept of conventional thermohydrolysis process where we have a low temperature thermal alkaline hydrolysis process. IP protected, and we have about 9 patents in North America. And Listech has received multiple awards from various organizations actually, that recognize biosolids and organic management. And Listech has many successful operations in the US, Canada, and Middle East now. I'll show a list of that actually later. So in general, about thermal hydrolysis processes. So a conventional thermal hydrolysis process, you may have heard about actually Cambys and Veolia's, XLS and all that. And there are a few others. Generally, they are at high temperature and pressure and about 140 to 170 degrees Celsius up to 130 PSI pressure, and requires high pressure vessels to actually treat that material. But they were the pioneer technologies in thermal hydrolysis at that time. So after that actually came thermal chemical hydrolysis process, I'll say TCHP or THP again. So they operate at much lower temperature, like 60 to 75 degrees Celsius and pH 9 to 11, or a little bit higher sometimes, depending on what process we are talking about. But there is no pressure vessel involved in it. So these processes operate at atmospheric pressure. So some of the commercial THP processes you can see in the list here. So most of these THP processes are from Europe. And then you can see the thermal chemical hydrolysis process. They were actually developed, a CNP process was developed in Europe as well. And Lystech was developed in Canada and has multiple products to offer, which we'll go into detail. And then you will also sometime hear biological hydrolysis process from Suez. That's a Monsell process they talk about. Again, it's at lower temperature. Just want to actually quickly go through what's the main difference between conventional THP versus Listech THP. So as I mentioned before, it's conventional THP actually always is pre-digestion, and it is more coming up actually as a post-digestion approach, but initially it was evolved as a pre-digestion technology, and it requires high temperature and high pressure, whereas Listech THP requires low temperature and is a physical chemical hydrolysis process, coming with the similar results. So you can see the process conditions, looking at 160 to 170 degrees Celsius versus 60 to 75 degrees Celsius. And then there are multiple step treatment process involved in conventional THP process, whereas actually in Listech THP, it's a one-step treatment process where you achieve a Class A product. Both technologies actually achieve Class A products at the end. And then another difference is the heat source, a high pressure steam boiler, and it requires a stationary engineer to operate there, whereas Listech technology does not require any special operator or a stationary engineer because it operates at low steam boiler, low pressure steam boilers. So installation wise, conventionally, actually, conventional THP processes are prior to anaerobic digestion. So they are dependent on anaerobic digestion there, whereas Listech process can actually be applied at undigested sludges or digested sludges equally to produce Class A material. Then when we go further down, actually, there is a high nitrogen centrate that requires further treatment in a conventional THP process, whereas Listech's post-digestion treatment process does not require any treatment of centrate because it works on the dewatered biosolids, and any dewatered biosolids material that comes to Listech reactor treated actually, and the whole product is used for beneficial purposes. And compared to product application, generally it's a high solids cake for land application in conventional THP process, whereas Listech is a high solids liquid biofertilizer product, generally about 13 to 15% range. And then that can be used for anaerobic digestion enhancement and as well as a carbon source for BNR system. And Listech's product always contain a potassium value, high potassium value, and that can, for so many crops, for many different crops, you can actually completely replace the fertilizer requirement using the Listech product. Biogas yield improvement coming from the pre-digestion versus post-digestion for Listech is in the range of 30% or higher, generally. So a little comparison of conventional thermal chemical hydrolysis process versus Listech THP. And again, I'm comparing to a commercial existing process. So both are low temperature physical chemical hydrolysis processes. The difference is in Listech, there is a high shear involved, high shear mixing involved, and that's why it can actually deal with much higher solids. So about 15% solids, Listech, it can be dealt in Listech treatment compared to conventional TCHP process where it treats only 4 to 5% raw solids. Again, one-step treatment process. Conventional TCHP are normally prior to anaerobic digestion, whereas Listech can operate post or pre-digestion mode. Generally, no side streams are generated in both cases, and the only difference, again, actually, it's a Listech material has a Class A biofertilizer versus conventional TCHP still produces a Class B for that application. And biogas yields are actually improved much higher for Listech because of the higher solids, degradable solids going back into anaerobic digestion. Just a quick overview of the Listech THP flow diagram. So you can see the material that is coming, a dewatered biosolids coming from a centrifuge or a press, or and then it goes into a Listech reactor, one unit that operates. It receives simultaneously cake, alkali, mostly potassium hydroxide and steam, and then it produces a class A Lystek, what we call actually our fertilizer product that goes into storage and further into for land application, beneficial land application as a class A biosolids. So how does it work actually? So, and I think I briefly touched at that already. It transforms biosolids into value-added product by a combined action of heat, high-speed mixing, and alkali, and that's where the Lystek's actually, IP is and patent protected process is, and so we, so there is, as I mentioned, there is no additional waste or side stream actually, to treat or manage there. And you can see one of the Lystek reactors is a LY10 module, about 10 cubic meter per hour unit for production, and you can see the high shear blade that what we use actually for mixing in this reactor. So it's, as you mentioned, it's about proprietary hydrolysis process that converts into a nutrient-rich pathogen-free. So nitrogen and phosphorus value retains within actually, and then potassium comes from the potassium hydroxide that we add, and it has few different beneficial functions where not only it helps in the hydrolysis process, but also it helps in stabilizing the final product when it goes into the storage. So there are no pathogen regrowths and all that happens in the storage. So what happens actually is this process disintegrates the biological cells and hydrolyzes the particulate organic material. And with the result, the trapped water within the dewatered biosolids are released, and the viscosity of the product actually dramatically reduced to almost 5-6 cups in centrifuges. And once you have the liquid product on your right side picture, you can see that how it flows from the reactor. You can actually, this material, you can store it as a liquid, you can transport as a liquid, you can land apply actually using conventional equipments actually for the land application purposes. You don't need any specialized equipment for this material. So this material, what you see flowing on the right side is about 13 to 14-15% power. So as with any THP processes, it converts the complex molecules. So that's the mechanism where starch or cellulose to glucose or proteins to amino acids and other nitrogen compounds, and lipids to smaller fatty acids. And there's a scanning electron microscopy picture there. On the left, you can see the untreated biosolids with the rod-shaped bacteria or round-shaped one or oval-shaped bacteria. You can see actually, a good count there. But then on the right side, it's a disintegrated cell after Lystek process. As I mentioned, actually, pathogens are always below detection limits. All the regulatory pathogens, fecal, E. coli, salmonella, and even poliovirus and Ascaris, we have done actually testing on that actually, and they're all below detection limits. So how Lystek THP integrates in wastewater treatment plant, and when we say actually it's one system, multiple benefits, by that we mean that actually Lystek actually comes right in the middle, right after the, whether it's an aerobically digested digestion plant or anaerobically digestion plant, after dewatering, it comes to Lystek, and the material actually goes to the storage for Class A fertilizer product, or in a LysteMize approach that you will hear later on more from Hannah as well. So you can actually feedback, because see, this is one of the hard to digest material that is coming out of anaerobic digestion or aerobic digestion. So once it is dewatered, it goes to Lystek, so it becomes much more amenable to further biodegradation, and you can refeed back into anaerobic digestion and produce more biogas. And because I'll show actually analysis of Lystek product as well. It has high volatile fatty acid content actually, if you can, and that can be actually, partially or completely replace carbon requirement from biological nutrient removal system. A plant, if in need of actually, a carbon source. So depending on the carbon requirement, actually you can refeed back into the BIR system and use as a carbon source and replace those commercial carbon sources like glycerol and methanol, etc. So just a quick one, how Listech meets the use EPA Class A criteria. So we use alternative 1, where the time and temperature criteria actually, that follows 70 degrees Celsius, 30 minutes, or if you go higher temperature, then lower time for them. And reduction of pathogen, metal levels, standard, you have to meet, and then the vector attraction reduction using option 9, injection to soil. But there are other potential Class A EQ options available to Listech depending on the benefit and applications and uses for EQ purposes. Mention about so that's another benefit for Listech product is it's a very homogeneous liquid, high solid liquid, 13 to 15, 16% range. When it goes to storage, it does not settle down. It remains homogeneous, like if I can actually, compare with like chocolate syrup or mayonnaise or, some of those products which are very homogeneous and don't separate out with the low viscosity, and they're fully pumpable material. And again, we have actually tested for long-term storage and without any pathogen regrowth actually for even a few years. So this is a Listech product composition, and that's where I mentioned about if you look at the values for soluble COD, RBCOD, and VFAs, and that actually adds the carbon value for either BNR system or feeding it back into anaerobic digestion to enhance the production of biogas and reduce further solids. Some of our facilities in Ontario and in US, and you can see we started actually first actually project in Guelph, Ontario, and then St. Mary's, Elora, and then Snod Petalford in Saskatchewan. Then again, another Ontario facility, and then first project and for on-site deployment in St. Cloud, Minnesota. Then the second one, actually, we have a demonstration plant for food waste and Listech treated food waste in Goleta, California. Then we are starting actually already the South Huron Valley first project in Michigan. Then we also started another project in Sharjah in UAE this year. And then we have another two projects at Commercial Township in Michigan that's coming soon under design and build, and the town of Erin in Ontario. We have actually advantage of regional installations as well, where within actually a certain like 100 kilometers or so, the municipalities, they send the biosolids for the treatment to our facility. So this was the first facility we developed in 2012 in Southgate, Ontario, that receives material from bigger cities like Toronto, Holt Region, Hamilton, and there are so many other actually, municipalities. They send either biosolids material or liquid biosolid material to us for the treatment. Another regional facility we have in Ontario, that's Iroquois. This is so the Southgate we own and operate, but Iroquois actually this has been transferred to another vendor. They actually use the Listech system to produce Class A biosolid for land application and all that. Then we have a Fairfield, California facility that we own and operate and with 150,000 wet ton capacity. And that receives biosolids from so many vendors around California area, San Francisco, and you can see a good list of generators that send material to our Fairfield facility. We have, as mentioned, actually 9 patents in US and Canada, and that actually, cover a range of technical processes we have developed within Listech. Received multiple awards and recognitions from various organizations in Ontario, as well as in US. So just to summarize my part actually here, before I give it to Hannah, it's simple to operate actually a system where you don't need any special stationary engineer to maintain, and most of the equipment used in Listech are very common to wastewater treatment plant, and for the operators is nothing new and very simple to operate. Small footprint normally. Most of our facilities are under 2,000 square feet area, where you can accommodate the whole system. And most of our operations currently are post-digestion mode, but we are also evaluating right now pre-digestion system as well at certain places. So as I said, it works with or without digesters. You can create a class A material using Lystek system from undigested or digested sludges, and does not have to be actually, so you can, one of our Ontario facility actually, when they evaluated Listech versus when they wanted to go for another anaerobic digestion system versus which was like 60 years old. So they found that it's much cheaper probably to apply Listech, and they did not. It's a smaller municipality as well, so they did not need any AD system there. So as we mentioned, one system, multiple beneficial applications for resource recovery, and so you can use the final product as a fertilizer product, class A fertilizer product, or you can refeed back into anaerobic digestion to enhance biogas and reduce solids, or you can actually also use as a carbon source. So it's we have actually a product designation with CFIA in Canada and with CDFA in California as a fertilizer product. So I'll probably hand it over now to Hannah to discuss further about Lystek energy production and carbon displacement.
Awesome, thanks, Ajay. Yeah, we can go to the next slide. So first I'll be talking about energy production. I'll go a little bit more in detail than Ajay has about LysteMize. So starting, yeah, then talk about an energy balance, and then the benefits of LysteMize energy production. So we can go to the next one. So for LysteMize digestion enhancement, what this is material which has undergone Lystek THP, and that's providing an improved feedstock to digestion, and this is enhancing biogas production and anaerobic digestion. This is due both to particle size reduction, feedstock homogenization, and viscosity reduction, as well as the solubilization of carbon that would otherwise go undigested. So it's creating more available carbon through this process. LysteMize is the process of providing this material, which has undergone Lystek THP, to anaerobic environments, and this can improve biodegradability and methane yield up to 70%. The results are proven through BMP testing. LysteMize also offers improved digestion kinetics and can improve the rate of biogas production by up to 40%. So it's faster liberation of that gas and a surplus of gas in comparison to anaerobic digestion alone. Yeah, so next slide. So there are 3 configurations that we have currently. We have a pre-feed system where Lystek THP is upstream of a digester. This is typically used for hard to digest wastes like citrus fruits or something like that. A refeed system where Lystek THP is after a conventional anaerobic digester, and that material is refed back into the digester. And then an intermediate storage configuration. And this is a configuration that does not require a facility to have a conventional anaerobic digester. So it's LysteMize on its own in place of conventional anaerobic digestion. That's typically applicable for really small sites that wouldn't have the capacity to warrant getting a conventional anaerobic digester. LysteMize can be used to enhance the performance of an existing anaerobic digester, as I said, or as a standalone process where there's no existing digestion infrastructure. And as I explained before, it works for large and small scale biosolids and organics producers. And that can be with continuous or discontinuous generation. So unlike a conventional digester, the Listech THP system and LysteMize, especially in the intermediate storage configuration, is essentially start-stop. So you don't have to continuously be feeding the system. And currently there are no economical energy recovery solutions for small scale organics and biosolids generators. So LysteMize is the only system that can be brought down to that small of a scale. Yeah, so then in this slide, I have an energy balance. So the following equation expresses the net energy generated through LysteMize biogas production. The energy consumed in the equation is all the electrical and gas consumption requirements of Lystech THP, LysteMize, and Listegrow production. And yeah, so as you can see, this is an energy positive process where the energy generated is a minimum of over 3 times the energy consumed. And yeah, and just at the bottom there, I've listed the equipment that we included in that calculation. So that would be everything we use, such as our boiler and disperser and pumps and all of the instrumentation that's consuming energy in our system. Yeah, next slide. And here I've listed the benefits of LysteMize energy production. So it's renewable green energy, which is energy source independent of fossil fuels. So you can technically run the system without any fossil fuel inputs. So if you were to have a cogeneration unit producing heat and electricity, you could run the boiler and all of the instrumentation and everything required of the Lystech THP system off that cogeneration unit. So it would be completely independent of grid. And this also leads into the next point where you have localized energy production. So you can have remote locations producing energy, which powers the system and then also provides them with excess energy to use however they would like. And that's really nice for locations that are off grid or maybe don't have connection to a natural gas pipeline. There are multiple options for energy output. So you can have biogas reuse on-site in industrial equipment, so direct consumption in a boiler, renewable natural gas sale into a conventional pipeline. So that's purifying and compression of the biogas, and then you can directly inject it. You can, as I said before, do a cogeneration unit and produce electricity and heat. Or you could compress the renewable natural gas that you purified and then use it to fuel compressed natural gas trucks in place of diesel. So all of those fuels are low carbon intensity fuels. And the other really nice benefit to LysteMize is that the feedstock for this process is climate change resilient. So there's always going to be biosolids. So it's not dependent on crops or something that could be affected by climate change. Yeah, so that kind of wraps up the LysteMize and energy production side of my slides. And then I'm going to give a couple example cases where we've calculated the carbon displacement of the system. Yeah, so in the first case, the base case, they had anaerobic digestion, dewatering, and landfilling of biosolids. And then in our proposed case, we have anaerobic digestion, Lystech THP, LysteMize, and Listech production. And this wastewater treatment plant or wastewater treatment facility was producing approximately 1,000 dry tons per year of biosolids, so pretty small. Yeah, next slide. And these are some diagrams of what they were doing. So obviously they're not utilizing any of the methane that they're producing. They're landfilling all of the organics, so wasting those nutrients. And yeah, they're not really getting any utilization out of their biosolids. So in the next slide, I have what we proposed, which is a LysteMize system, and then that biogas collection and biogas utilization and energy recovery. And for this plant, they're considering more so the RNG side of things and injection into the pipeline. And then obviously recovery of those biosolids and application of it as a fertilizer. So fully nothing is going to waste now. And then in the next slide, I've summarized all of this with actual numbers of how it works out for carbon calculating. So the use of biogas on site and generation of Listech provides large carbon displacements in the form of obviously avoiding the landfill and the methane production associated with that, and the recovery of nutrients, replacement of natural gas with renewable low carbon fuels, so using that RNG in place of conventional natural gas, nutrient recovery and replacement of mine fertilizers. So in the application of Listech, you're replacing the mine fertilizers. And then also our system does provide a reduction in centrate production because we do not use the centrifuge to make 25% solids biosolids. So you've reduced the electrical and polymer consumption required of your centrifuge, and then also you sequester carbon in the soil. So this resulted in a 2,797 ton reduction of greenhouse gases avoided annually. So that's expressed in carbon equivalents. And then that can also be expressed in the number of gasoline burning cars taken off the road per year. So that would be 608. And then over the 20-year lifespan, that looks like 12,160 cars removed from the road in that 20 years. Yeah, and then in the second example case, they were doing aerobic digestion, dewatering, and composting, and that Class B application of biosolids. And then the proposed case is replacement of this with anaerobic digestion, Lystech THP, LysteMize, and Listech production. And this wastewater treatment plant was producing approximately 4,000 dry tons of biosolids per year, so quite a bit bigger than the last one. And then I have these slides. Sorry, this one, if you skip to the next one, this is the baseline case. And then if we move on to the next one, the proposed case is very, very similar. It's just in this circumstance, we proposed to do cogeneration instead of the RNG. The use of electrical and heat on site and generation of Listech would provide large carbon displacements in the form of producing green energy, whereas in the past, obviously they're not producing green energy, they're consuming a lot of energy in aerobic digestion. So by replacing that with anaerobic digestion, they have that pathway to produce energy on site. And then again, reduction of centrate and electrical and polymer consumption in the centrifuge, and then replacing composting with Class A Listech fertilizer, and reducing the total transportation and mass transported offsite. So this last point, with composting, there are 2 steps of transportation. You'd have to transport the biosolids to the composting facility, add a lot of amendment to it, tripling the volume, and then transport that offsite. Whereas List2Grow is one transportation step of significantly less volume because you're not incorporating that amendment. So there was a huge reduction in the trucking emissions when comparing composting Class B to transporting List2Grow. And then in this, implementing Listech THP would result in 2,170 tons of greenhouse gas emissions avoided annually. And I think this is interesting because it's pretty similar to the last case, even though when you think about it, landfill, this wastewater treatment plant was producing a lot more solids, but when you're looking at what they were doing before and comparing to that, obviously composting is a lot better for the environment. So in that case, these kind of worked out to be around the same carbon savings, even though this wastewater treatment plant is a lot larger. And that's the equivalent of taking 472 gasoline burning cars off the road per year. And over the 20-year lifespan, that's 9,440 cars off the road. Yeah, and this is kind of a fun slide to finish it all off with. So just based on nutrient recovery and carbon sequestration, Listech since 2008 has produced 1.7 million cubic meters of fertilizer, and that corresponds to recovering 254,000 dry tons of biosolids and organics, and that is 9,000 tons of nitrogen and 13,500 tons of phosphorus, which has been saved from going to the landfill or incineration. And then nutrient reuse and carbon sequestration through these two mechanisms and land application of the fertilizer, there is 126,500 tons of carbon equivalents avoided since 2008, and that's the equivalent to the annual emissions of 28,000 gasoline burning cars. So that's just a little summary of just by applying fertilizer, that's how much carbon has been saved. Yeah, that's all we have. So thanks so much.
You know, thank you, Hannah. We have some questions lined up. Are you two ready?
Oh yeah, always.
Oh, there you are. You weren't on camera before, and I did hear your dog barking at one point.
You did hear that. Okay.
All right, you two. So the first question is the THP unit serves as both storage and LysteMize and LysteMize and biogas. Can the use of the unit eliminate the need for biosolids anaerobic digestion for the purpose of biogas generation? So does fermentation take place in that unit? And can it replace ED, I guess, is the...
Yeah, I think they're talking about the intermediate storage configuration. So in that, yeah, it does serve as storage and as a digestion vessel as well. So because of the nature of List2Grow, it's entering that container, 70 degrees Celsius, homogenized and optimized for digestion. So I did say this is best for wastewater treatment plants that are smaller. So you're not going to get the exact same volatile solids reduction that you would with a conventional digester because that's an optimized vessel. But for a facility that can't have a conventional anaerobic digester, this is a great solution to still be able to produce biogas and have storage at the same time. So I hope that kind of answers it.
Yeah, and just to add Hannah's point, actually, so it also depends on, so if you already have anaerobic digestion and Listech coming from the back end, so the material is already digested quite a bit, and then there's a more additional digestion benefit comes. But if a facility does not have any anaerobic digestion, then you have actually a undigested material coming with lots of carbon and lots of actually volatile solids. So when it goes after Listech treatment to the storage, that can actually have more biogas producing within that facility compared to actually AD facility versus undigested material facility.
So Sarah, if that did not answer your question, let us know. The next question, again, great presentation was the comment. Any experience with feeding grease trap wastes? Does Listech treatment process break down the grease to the point where it's not a problem down the pipe?
So in the past experience, actually, when we dealt with paunch manure and the fatty material coming out of the their skimming system and DAF and all that, DAF floats and all. So what we found actually is on its own, when it is greasy and fatty material, it does not actually go very well because with the alkali, this saponification happens, right? And in our system. But if there are fibers and biosolids available along with the greasy and fatty material, it does go very well. So not on its own, but yes, along with the fibrous material or biosolid material, it treats very well. Yeah. And actually, in fact, we have a patent on that as well, on that process.
Of course you do. All right, there's lots of questions coming in here.
Sure.
Does the LysteMize energy production happen through capturing biogas by storing the THP process digestate in a closed tank? How does this compare to the amount of biogas that can be produced and captured in a typical anaerobic digestion?
I think, Ajay, if you move to the next slides, I have some diagrams. So there's kind of two answers to this. So yes, if you go to the last one on here, in this configuration, yes, the biogas collection is happening in that storage tank. But if, Ajay, you flip back to either of the other ones, the biogas collection is happening in a conventional anaerobic digester. So we're adding Lystech THP as an additional boost of biogas. So for a facility that Ajay already said has anaerobic digestion to begin with, we're adding that boost. So it works for both.
Okay. All right. I think that one's us. All right. I warned you guys you were going to get this question.
Okay.
Does the Lystech process break down PFAS compounds?
That's Hannah will answer, not me.
You need an engineer to answer that one?
No, actually, you see, we are actually working on this thing actually, and just like metal removal, when the metals were a problem and ESOX were a problem, we worked on actually those areas, and we are currently working on PFAS. A first actually, response is actually, it's hard to actually degrade in our process condition, but there are some actually indicators that yes, there is a possibility, but we don't have lots of results to share at this moment. But we are working with actually some universities and some other organizations on PFAS aspects. So.
And are you looking at it in air emission wise, all aspects of?
A couple of things, whether our treatment system itself actually does anything, or it changes the chemical structure, and a byproduct will be more biodegradable in soil environment or in other biological environment. Those are the aspects actually we are looking at, but we don't have actually enough results to really say.
Well, we're all wishing you good luck with that. And don't feel bad, really. None of the processes we use right now are doing anything, but.
Yeah. Hannah, you want to add anything to this, or?
I guess just, if Michigan is an example, then they did source treatment, and they had 50 to 90% reduction in all their impacted wastewater treatment plants. So
it's the source.
We have facilities there, and they don't have PFAS issues because they have that source treatment. So
and we hope actually that if you remember the PCBs problem from transformers, right? And that was a huge issue, and it was controlled at source. Asbestos, for example, another one, those were controlled at source. And then we're hoping actually it may not be as issue in biosolids case, but yeah. And the water is more concerning, by the way, more than actually the biosolids, but
Yes,
I'm not an
I
expert
totally
on that.
agree. I totally agree.
Mm.
All right, another question for you guys. How does Lystech THP compare to biological hydrolysis as an AD pretreatment?
Okay. I can answer that actually. So when biological hydrolysis was started, actually, it was like a few different compartments before the material goes into anaerobic digestion. So the hydrolysis, biological hydrolysis happens at about 35, 40, 45 degrees Celsius. So that was actually the initially, and then they, in the newer processes, they have added actually a 75 degrees Celsius, 70 degrees Celsius thing to, so that actually they can achieve a class A material. So before it was a class P material that will be generated from anaerobic digestion. So I have not seen any commercial process that has class A configuration, but so it takes about 2 to 3 days before the material reaches to an anaerobic digestion in biological process, because it's happening at 40 degrees Celsius or so. And some of the bacterial processes at higher temperature are slower. And compared to Listech, you can achieve the same results within 30 minutes of process.
Okay.
At Listech thermal chemical hydrolysis process. Within 30 minutes, you see the same amount of actually, VFAs or soluble carbon and all that. What you see at extreme temperatures like conventional THPs at 150, 170 degrees Celsius, you achieve the same kind of product in the Lystech conditions, and that's where the IP is, right?
Okay. And here's a great question. So thank you for answering the previous question. And does this mean that for water resource recovery facilities looking to produce RNG without a digester, they can go directly to the Lystech system?
I would say somewhat yet. Yes. But Hannah, I think probably she's going to reply.
Yeah.
That.
Yeah, this is true. Yeah, you can just go directly. If you want to flip to the last slide again, this would be that.
Oh, sorry.
Oh, it's all good. That storage configuration. So this has been proposed for really small facilities and also kind of or the regional facility where there again isn't digestion on site if they're collecting the biosolids and then treating them there, that this is proposed again there, that kind of storage. But yeah, it's beneficial to both. With this, you don't have as much solids destruction as a conventional anaerobic digester, but overall, the gas production, the net gas production and energy production is higher than a conventional digester, because in a conventional digester, you have those heating elements and the electrical consumption, and that consumes a lot more energy than our system here. So if, yeah, you're purely looking for RNG production or gas production, and that is the main goal, this system and this configuration of it is probably the best bet.
Thank you, Hannah.
Yeah, and this is something actually the latest addition to our Lystech THP, LysteMize, LysteGrow, Lystek we talk about actually, and we have to give a name actually to this, and that's one of our latest patent as well actually. Just allowed by US patent office. So
you're continuously tweaking this system.
Yes, absolutely.
Yeah.
And then we're always looking for something new or something, unique happening in our process. We are still learning actually, I'm still learning actually from Hannah and others that what happens into when you go deep into the Lystech process. Right?
There was a great quote in the Dark Matter book, like that she said how running this operations is much of an art as a science. And sounds like, yeah, you've got a lot of learned
Yes.
learning behind that.
Yeah.
All right, I don't think we have any more questions, just a few comments there that you guys can see, thanking you for the presentation. cheer for co-digestion and renewable energy. Let me just see. All right, I think I have all of the questions. Yeah. All right. I think you've gotten all the questions, and I really appreciate it. We're sort of coming to the end of our webinar time here, but I want to thank Ajay and Hannah for all of the work that you're doing, all of that research, and for presenting for us today. And thank you to everyone who joined us. Our next session will be July 22nd. Should be of interest. We're going to hear about a new biopolymer for wastewater treatment that's made from shrimp and crab shells and other seafood residuals. So check out our events page for more information. And if there is something that you are very interested in lunching and learning about, please shoot me an email or give me a call. I'd be happy to make that happen. Thanks again to Listech, Jay and Hannah.
Thank you.
You guys have a great weekend. Everyone have a great weekend.
Thank you.
Thank
you
you.
all.
Thanks. Save the chat here.